Hello guys, welcome to my video. So today I'm going to be answering the May-June 2023 paper 1 physics paper. So here are some of the constants that you'll be using, and here are some of the formulas. Some of the most important formulas are the Doppler effect, the electric current. Also you have the formula for updrafts here, but it is important to know most of these formulas by heart. Okay. So the first question, which unit is not an SI base unit? We know that the ampere is the SI base unit for current, the kilogram is the SI base unit for mass, the second is the SI base unit for time. Therefore, our answer becomes C, which is the coulomb, because we know that charge is equal to the product of current and time. And current is measured in ampere, time in seconds. So the coulomb is actually the ampere and second in terms of SI base units. So our answer is C. Okay, moving on to question number 2. The question is saying, which is the best estimate of the number of atoms in a piece of metal of volume 50 cubic centimeters? Now, these MCQs are very tricky and they've been coming a lot in these past few years. They involve making reasonable estimates. Now, I've made a video about how to make some estimates. You can check that in my channel. But it's very important to understand that there is no particular formula for answering these questions. You just have to tackle them as they come. They can ask you really random things like maybe calculate the volume of a person, and you just have to make estimates that maybe assume the person is a cube, or assume the person is a rectangle. What would be their height? What would be their width? You can even measure yourself in the examination and sort of see what is your height, what is your width, then you multiply. But the most important thing that I have to emphasize on this, the most important thing are these particular powers. I would say it's very important to be at least close to these values as possible. So in this question, the number of atoms, the only method that I've been able to come up with involves a little bit of chemistry. But if you know other methods, please do share in the comment section. Okay, so let's start. So I'm told that the volume is 50 cubic, okay, centimeters, right? I know that if I take water, let's take water for example, okay, water is a density of 1 cubic centimeter per gram. Make sense? Okay, so a metal probably has to have more density than water. Okay, so we can assume that, okay, if water weighs 1 gram, maybe the metal has to weigh much more. It might weigh maybe 50 grams, okay, per cubic centimeter, right? So if I have 50 grams in 1 cubic centimeter, I have 50 cubic centimeters of my metal, and if I multiply by 50 grams, I end up with 2,500 grams. Okay, so I can assume that this piece of metal has a weight of 2,500 grams, right? These are just estimates. You can really use any density that's just above than that of water. You get an answer that is at least close to that true value. Okay, now from chemistry, we know that the number of moles, this is very important to know, is equals to mass over mr. Okay, but the number of particles is equals to, okay, number of particles is equals to moles times the Avogadro's constant, 6.02. Okay, so it's moles times 6.02 times 10 to the power of 23. So that's the formula to find the number of atoms, number of particles in a certain moles of a substance, right? So if I have 50 times 50, which is 2,500 grams, how many moles of that do you think I have? Now here again, I can make another estimate from chemistry. I can just pick any MR of a metal that I know. So if you don't know, if you haven't done chemistry, the MR is just the relative mass of a molecule, or the relative atomic mass of of an element, or the atom of an element rather. So it's how much an atom weighs as compared to the unified atomic mass unit. You do that in physics. So if I have 2,500, let's assume I take 40.1, just an estimate, it's for calcium, and I multiply by 6.02, Okay, so it's 250 divided by 40.1 times 6.02 times 10 to the power of 23. That will give me an answer of about 3.75 times 10 to the power of 25. Okay, so I have made three assumptions here: that it has a density greater than water because I knew the density of water, and I've also said that if I have that, I can find the number of moles, and I know that I can pick any metal that I want. You could have easily used maybe 100 here. Any value could have really worked. It would give you an answer at least close to this particular true value. Okay, and since our answer is okay, and since our answer is 3.75 times 10 to the power of 25, the closest answer to that is B. Moving on to number 3, we're given a copper wire that is a true diameter of 42, and a builder is measuring the diameter 5 times, and you obtain these readings. Okay, so which describes the builder's measurements. So the first thing to notice here is that they either have to be all accurate, or they either all have to be not accurate, or they either have to be all precise, or they have to be all not precise. So if we to go to our question, the true value is 42, but this one is 48, this one is 47, 48, 48, 47, meaning that these values are nowhere near this particular true value. Therefore, these values are not accurate, meaning that A is wrong and B is wrong, and we're left with C and D. So we have to decide, are they precise or are they not precise? And if we were to look at our values, look at this interval, they are differing by about 0.02. Here they're also differing by a small amount, the same as going here. So roughly they have to be precise. So they are precise, but they are not accurate. So our answer is D. Moving on to number 4, we're given two forces that weigh 10 newtons each. So this force and that force, and the angle between them is 120. So we know that the resultant force will be acting in that direction. So we can use the parallelogram rule, which is quite easy to use. So if we were to complete it into a parallelogram like this would be our resultant force. We know that if there's 120 degrees here, they have to be 60 degrees here. Okay, so if we draw a parallelogram, there has to be 60 degrees here. So we know that this is 10 because it's the same at this value. So if this is 10, I can find the value of this resultant force R. So I use the cosine rule to find the value of R. The cosine rule, which is R, is equal to the square root of 100 squared, 10 squared, which is 100, plus 100. You subtract 2 times 10 times 10 times cos of 60, right? So this gives you your value of R to be the square root of 100. Therefore, R is equal to 10 newtons. So our value of R is 10 newtons, which is B. Okay, moving on to number 5. One object moves directly from P, so object is here, and then it goes to this value, or it goes to this point R. In a shorter time, a second object moves from P to Q to R. Okay, and then the question states that which statement about the two objects is correct for the journey from P to R. So as you can see, this object has moved from this point up to that point, and this object has moved from that point up to that point. But at the end of the day, they all have moved from P up until R. So basically, they have the same displacement. So our answer is is C. Okay, they can't have the same distance simply because that one has moved a longer distance. They also can't have the same speed because the other one is taking a shorter time. So the times are actually different. Okay, moving on to number 6, we're given a ball that is kicked with an initial velocity. So this is initial velocity of our ball, and we're given this angle 50 degrees to the horizontal, and we're told to assume that A resistance is negligible. Whenever you see this word assume is negligible, means that the value of acceleration G has to remain constant. Okay, so if we were to look at our question, we are asked to find the maximum height above the ground that the ball that is reached by this ball. Okay, so we know that if I hit this ball, it's going to move in a projectile motion. So it's going to follow, let's say, this trajectory. So I want to find this height, the maximum height that this ball will reach. Okay, so at the maximum height, we know that the velocity in the y direction will be 0. Okay, because there is no component in the vertical direction at that particular time. But our formula, we know that our formula says that v squared is equals to u squared plus 2as. But this u is the component of u in the y direction. And from our formula, the component of u is 12. Okay, so the component of u is 12 here, meaning that this value of uy also has to be 12. Okay, but it has to be 12 sine 50 because we're taking the component in this direction. Because if we go here, we resolve it into two directions, uy, and we resolve it again into ux. So we've resolved it into two components, and we then take this one to be our uy. So the formula to find our height, if we make h the subject of formula, in that formula, we know that h will be equals to u sine theta squared divided by 2g. And if we were to go back to our formula here, our u is 12 and our theta is 50. So our h is equals to 12 sine 50, all of that squared, divided by 2 times 9.81. And if you compute that, you end up with a height of roughly 4.3. 0. So our answer becomes C. Okay, moving on to number 7. We're given a camera drawn of this mass. Okay, so all of this weighs 1.2 kgs, right? So we're told that it has 4 propellers. So 1, 2, 3, 4. Okay, and in a time of 1 second, each propeller pushes a mass of 0.40. Okay, so what's happening here is that this propeller is pushing a mass of air down. This propeller is pushing a mass of air down. That propeller is also pushing it down. That propeller is also pushing a mass of air down. And they are pushing 0.40 kgs of air down, all of them at the same time. So we can find the speed that is moving. We have to apply certain laws that we know from Newtonian mechanics. Okay, so we're going to explain that a little bit. So we know that our force, okay, our force is equals to ma, but this is not the general formula. This comes from the rate of change of momentum. We know that force is equals to mv minus mu over time. Okay, so from this we can apply differentiation, because we have to change the velocity and we have to change the time. But generally, we get this formula that is very important for you to know, over t plus m dv over dt, meaning that the mass can change or the mass can remain constant whilst the velocity is changing. So we apply this formula. That means this will be 0 because this mass is remaining constant. So there will be no dm dt. Or the velocity of this object could be constant, but the mass could be changing. So I apply this formula and I don't use the other formula. So this is generally a formula that you use in order to find this. So in this question, it is the mass that is changing, but the velocity is remaining constant, because we want to find that constant velocity. So I can apply the formula F is equal to V dm over dt. Okay, so by applying this formula, if I find the force that is being acted upon on each propeller, or the force that each propeller is causing, and I find this rate of change of mass, I can easily find this velocity. So in our question, we're given that this O has a total mass of 1.20. So I can assume that each propeller is taking a certain portion of this whole mass, or is taking a certain portion of this whole weight, and we know that weight is equals to the mass times g. So if I multiply this mass times the gravitational acceleration, which is 9.81, okay, I'll be able to get the total weight of this whole object. And once I have the total weight of this object, which is 1.2 g, once I have this total weight, if I divide it by 4, I'll end up with the total weight that is being acted upon by each propeller. So each propeller is exerting this equal force upwards so that it can be able to maintain this thing in motion. So what is happening is this weight is acting down, the force up here, the force up there, the force up there, the force up there, and it maintains this thing in equilibrium. So if I apply my formula, I can then be able to find 1.20 times 9.81, and I divide by 4. It should be equal to my velocity. What is my rate of change of mass? It's 0.400 divided by 1.00. So essentially what we are calculating here is this value of V. So that gives you an answer which is basically 36, which is this one. So the basic idea of this is always to remember that whenever you have these kind of questions, you have to figure out what is changing. Is it the mass or is it the velocity? Always in these propeller questions, they can be drawn questions. There can be a lot of questions that are moving on. Find what is changing. What will be changing here is the mass. Apply your laws. You know your formula. What is changing? What is remaining constant? And then you know that there are certain forces which are acting up. They'll be distributed amongst each drone. So you already have your force. You want your velocity, and you know your change of mass, and you can find anything. Okay, moving on to the next question. An object rests on Earth. Okay, so we're given an object resting on Earth, and we're told Newton's third law applies. So we want to find the arrow which represents the other force. So this is basically the weight acting downwards, and the weight is the force of the Earth on this object. Okay, so that means this object will also exert a force on the Earth. So it will pull the Earth upwards. Okay, the Earth will pull this object down, and the object will also pull the Earth upwards, but the Earth cannot feel it because the Earth is too big, so I cannot cause a change in the velocity of the Earth. Okay, moving on to the next question. A mass, so we're given a small ball which is held at the surface of a liquid, and it is released from rest. That is very important, meaning that the velocity at the beginning is 0. Without even looking at the question, I can eliminate this one because it's assuming that the velocity is not 0, meaning that D is already out. Okay, the ball is a velocity v and a viscous drag force which acts on the ball. Which graph shows the variation of the velocity with v? Okay, so it is very important to know this particular formula. You don't really have to know it, but it's not really in our syllabus, but it's a very important formula to know. So there are two methods again to solve this, and we're going to walk through each of them. Okay, one more question left. Okay, so basically we know that the viscous force is given by this equation. Okay, right? So from this equation, we know that this force and this velocity, all of this is constant. Okay, so if we remove it, okay, so if we remove all of that, we'll end up with this force being directly proportional to the velocity. But that formula is not in our syllabus, so you might not know it. Here's a second method to know to find this relationship. You know that v squared is equal to u squared plus 2as. Okay, but this object is starting from rest, meaning that there is no initial acceleration. Okay, so we are using this velocity and this formula, so we're left with our formula being v squared is equals to 2as. But you know that f is equals to ma, so you can substitute this acceleration. Okay, so v squared will be equals to 2f over m times s. This is constant, this is constant, so your velocity and these ones are related. So v is directly proportional to v squared. Okay, so if I have this relationship, I can easily go on to my graphs, and I know that the relationship for a v is equals to f squared graph generally looks like this graph. Okay, so if I have v is directly proportional to v squared, this is a cubic graph. So generally a cubic graph has to look like this. Okay, so this graph therefore makes my answer correct to be A. So whenever you are given questions about graphs, so it is important to identify two things. Number one, identify the equation. Okay, and after you have identified the equation, the second thing is identify the relationship in that equation. Okay, once you have the relationship in that equation, you can then be able to draw the correct graph, right? And then some important relationship that you should know is that if it's a cubic graph, let's say if it was v against the square root of f, the graph then has to be the graph would then have to be a cubic graph. So it then has to be something like this. Okay, if it was v against f, because we know that this graph is the graph for the square root relationship, right? If it's a squared relationship, generally becomes that graph. So our answer is A. Okay, our answer becomes A. Okay, moving on to question number 10. We're told that we have an object of mass m that is moving at a speed of v along a frictionless horizontal surface and is colliding head-on and with a stationary object of v. And then after the collision, the mass rebounds with a quarter of its initial kinetic energy, and we want to find the speed of the object of mass m after the collision. Okay, so let's go down. Okay, let's explain this, what's happening. So before, it's moving with the speed v. So it's going to come and it's going to collide with this object and it's going to move back. If it rebounds, that means this object has to move forward. Making sense? So before collision, the momentum will be mu. After collision, because this one is stationary, it has no momentum. After collision, this one has to rebound with a negative m u2. But I don't know this u because I don't know what speed it's rebounding with. And then, so it will be mv, okay, is equals to, or mu rather, is equals to negative m u1, okay, u2, sorry. I don't know what the speed is moving on with, plus 4mv, because it's moving in this direction, so it has to be positive, okay. So I can cancel out these masses, okay, and my equation simplifies to u is equal to negative u2, okay, plus 4v. My question wants me to find this v, okay, so let's go and look at what we are given. We're told that it has a quarter of its kinetic energy, okay. We know that ek, the kinetic energy, is equal to half mv squared, okay. That would mean that if this kinetic energy for a constant mass is directly proportional to v squared. So I want you to get this following ratio. If I double the velocity, the kinetic energy increases by 4. Okay? If I half the velocity, the kinetic energy will increase by what? The square of 4 will increase by a quarter. So if it has a quarter of its kinetic energy, what does it tell me about the velocity? That it was initially half of the velocity. Okay? So if we were to go back to our initial question, that would mean that before the collision, okay, before the collision, I had we had established this relationship before, u2, okay, plus 4v. So before the collision, this is half. So u is equals to negative half of u plus 4v. So if this goes to the other side, I end up with 3 over 2 u is equals to 4v. Okay, let's clean that up. So if I say 3 over 2u and I divide by 4, that should be equals to v. So my v will be equals to 3 over 8u. So my answer will be D. Okay, so that's the first 10 questions. See you in the next video.